Hello, my name is Robin Mitchell, and today Electropages is here at PCIM 2024 in Nuremberg, and I'm joined by Ralph from ENNOVI. Thank you for having us.
Thanks for being here
Today.
Right. Hey.
Now, if I remember correctly, we actually saw you guys back at the Public Tech event, I think about last year.
That's correct. That's correct.
And you showed some pretty cool stuff. So I'm quite curious to see what's going on here today. So we've got some different bits and bobs in acrylic or glass cases.
Nice.
Ooh, glass case, that is.
Classy.
Very nice.
Classy.
So take us through what's going on today.
Yeah, so my name is Ralph Samling, basically. I'm portfolio director for ENNOVI in this company. So what we basically want to show in this show is that our really differentiator is having released press pins available for the market, which we got automotive released and approved by tier 1s and OEMs. So this is basically our core competence. And what we're recognizing momentarily is that the move to more reliable interfaces, we see more and more tier 1s and OEMs utilizing more and more pressure pins. Reason being that the pressure pin has a more reliable interface to the PCB instead of soldering. So that's basically one of the key elements of difference.
So press fit, as I understand, it's not a solder connection. It's push into a via or a hole.
Correct.
And that's more reliable than solder.
Yes, because if you think for solder, right, solder has there are many differences. So one of the key differences is soldering, you actually have to heat up the part. So which means you're adding stress to the part, right? Otherwise you can't make a connection. So the insertion of the pressure pin is just cold, right? You just press in the pin.
That has actually never occurred to me at all. That you
have to heat up the whole board.
And so you're going to what's it called when you heat a piece of metal and it kind of changes
it changes structure. So you have to use high temperature plastics.
Heat treating and stuff.
So you don't have that. Yeah. So all the effect of all the side effects from heating up you don't have. The other thing is that solder has the negative things. You can also have bridges, right? Because if something goes wrong with solder, you have issues, right?
Yeah,
so
definitely.
press fit is basically just a shape. You have the hole right of the PCB. You press it and you're done, right? So that itself is a very consistent quality performant part. So this is so you don't have any variations like you have a solder, right? The temperature might deviate, right? So you don't have that, right? So you have no residues of flux, but you have in soldering.
But then my question would be, how can press fit be used in an automotive environment where you've got things like high vibration, high shock, and stress? So how can that survive that environment?
So the connection of the press fit pin is actually stronger than a solder, because if you have
really,
it is. Let me explain you why. Because solder, you just have a connection to a copper part of it, right? And if that by shock vibration, you get everything moves, right? Which also can mean that connection in that PCB can actually break and crack. And so press fit is basically very high force, which you keep into that PCB, so you can't actually get out.
And so I suppose what you're saying with solder is that is it because it only forms a contact on the skin of the part, and so. Are you saying that's where the risk comes from, or is it the fact
so you have multiple different solder widths, right? So you have through hole, which goes right through, right? And you have just on the top surface, right? So SMD, which of course that's even lesser reliable, right? Because then really can crack off, right? So but solder with through has basically still it's a reliable interface, right? Yeah. But because of the nature which you just mentioned, right? So all the side effects, it causes some reliability concerns. That's why you see a transitioning now from, especially for when we go into L4. Autonomous driving from
I still struggle to see. It's amazing to see that press fit can be better than solder. I honestly
you never thought about it, right?
No, because if someone said to, because we're actually, funny enough, I'm actually designing some stuff for a company at the moment, and we're thinking about how we're going to connect two parts together. And I thought solder, I actually thought about press fit, and then someone said, "Oh, press fit won't be able to work in these vibration environments." But what you're saying is actually that's not true. It's the other way around.
Yes.
Honestly, it's.
And you see what you also see, right? You see a trend of everything gets smaller, right?
Like these ones up here.
So what you recognize that this is open 4, and we're now developing open 2, so it's half of that size, right? So very small pins. So what you can ask the question, why we do these small pins, right? Because if you automotive going to high speed, right? High data connection is basically you need as minimum amount of copper you like to have as pins. So as smaller the pins are, the better the performance actually is.
Is that where things like the skin effect take effect as well?
Yes.
So all the signals around actually just the outside part, so you shrink it down. So if you go for high speed, you want to have a unique and a fixed size of the part. So it means if I add solder, it's always a variation. Yeah, pin is its size, right? It's a fixed size. You have a high-speed stamping press, which does make the parts stay consistent. And so just to be clear, this is all automotive grade.
Yes.
And you're trying to make them as small as possible. Does that mean you're anticipating things like, because you talked about high speed, I take it you're anticipating things like AIs on
yes.
Any sensory thing, anything that involves massive amounts of data.
Correct. So, of course, if you go to level 4 autonomous driving, right, you have a lot of data which you have to process.
Absolutely.
So you get this process, which of course, you need to process, and the data speed goes up to 25 gig.
Oh my God, 25 gig?
Yeah, so we're now between 10 and 25. We see the trend really going up to 25. If you go to that 25, it's a bit of the same happening in the datacom industry. Also there you see a lot of press fit pins, it's very small size. So automotive is just going to go the same way, right? Incredible. So we just have to make that happen, and we are one of the enablers to with the development of press fits.
I can see that, and I'm still amazed that press fits better than solid. I'm still not getting over that. So we've got some other stuff over here. So we'll just take us through.
If you see the products here, right? So on the ECU, right, you have these high pin count connectors, like we see here, right? So that could be a seat control, could be an ADAS controller. So we basically, as utilize our press fit pins, right? And a multi-pin with different size, so there's open 4, open 6, the same product.
So just to be clear, this is a connector using press fit pins.
Yes.
So when you put that into the PCB, you push that in.
Yes.
And you don't solder it.
No. So basically, if you zoom in, right? If you zoom in, so you see shoulders here, right? So that you come with a knife and you push on those shoulders and you press into the board. But it's a one-step operation. So you put the product on the board, and the press comes down, it's fixed, done. No heat, no nothing.
And I think the reason why I still have it in my mind about thinking it's being reusable is the fact that these are not. You don't pull these out. Once they're in, they are in.
They're in.
And so that's where the differentiation comes in. It is not a typical connector where it goes in, goes out, goes in, goes out. No. It's push once, never comes out.
Never comes out of it. It's a one-time operation.
And so, oh wow.
So of course you can always push it out, but then
you destroy the connector.
And so even the board is to some extent
you're going to destroy the piece. But that's a good thing because it's been pushed in so strong, it's not coming out. It is completely reliable. And you can see, if you zoom in, you can actually see the tiny little I'm not sure what you call it. It's the bulge. So when it goes in, it obviously it compresses a bit.
So you have different shapes, right? This is what you see here is eye of the needle. So you see it's an eye, right? So what means that basically the eye, when you stop pressing it, it moves slightly inwards, right? So, but the normal force between the eye, which is created by pushing into the PCB, it goes in that side, right? So that force gives you that reliable interface, really high force. So,
and I suppose the more you have, the better it's going to be as well. So I suppose you would want to encourage more connectors.
No, that doesn't have to be. So every hole itself will have. Sure, if you have multiple connectors, they somehow work with each other because you see the force going through the PCB. But somewhere you have to if you want to utilize press fit pins, you somehow have to balance between the insertion force versus retention force. So for manufacturing, you would like to have low insertion force
because it's easy to produce.
And not only that, but it's easy to actually to your point to push the connector onto the board, and then it's basically the retention force to make sure it gives a robust feeling, right? So basically there are requirements which are fixed in the standard committees, so which will specify those boards and specify these performances, and basically we just need to be in compliance. And every tier 1, every OEMs have their some unique requirements, and you just have to make sure you accommodate those. That's that connector. So if we move here, right, you see radar maybe. So very similar, right? So this is high pin count. Oh yeah, this is radar. You see the pins again.
The eye ones,
You see the eye then as well.
Yeah.
So you see here this one's still an open 6. You see that's I would say the existing generation radars. The new generation radars all have 0.4. So you see already the transition to a smaller size, right? So we're going from a 0.6 to a 0.4.
So that's 0.6.
That's 0.6.
And you're working on 0.4, or you already
0.2. We're working on 0.2. So 0.4
So the demonstration is already too old.
The thing is, we are customized solution providers, so you have to be careful. So you have to put products there which are on the market, right? Which are long term in the market. So that's why someone is a little bit challenged, of course, to show our latest and greatest because of the customer NDAs.
But to be completely clear, that's still impressive, considering the fact, like you say, it's press fit, no solder, it doesn't damage no heat damage, all that kind of stuff.
But just imagine, right? So if you the reason why people really like the press fit is think if you're the radar manufacturer, right? You take this product, comes in like this, right, on the board, right? Somebody comes with a PCB with your technology on it, and you press it, and you're done.
And there's no need to put it through
heat, no nothing.
Now, I suppose the other thing about things like soldering as well is, if you've got a through-hole point, through-hole parts, yes, you can solder from the underside manually, but if you've got SMT parts, the whole thing has to be reflowed.
Correct.
And so if you've got sensitive modules that have already been reflowed once, you don't want to keep reflowing them. So the press fit, it just eliminates that completely.
Correct.
That's really, really cool.
So from a manufacturer perspective, for the electronic manufacturer, when he's convinced and moved over, he doesn't want to move any more back. Because to your point, you take the board, press it, and you're done, right? And it's also, think about it from a reliability perspective. So we can say it's a more reliability phase, but something else as well. So if you do it right, and you say you do something wrong, you have to throw away the part. So think about
you do something wrong with soldering, you just keep doing it until it works.
Let's rework it, right? Let's rework it. No one sees it, right?
I'll tell you right now, I've seen that firsthand when I was working at a company, and I saw people doing it wrong, and then just kind of like rejigging the whole thing. I'm thinking.
And then imagine that this is an L4, level 4 autonomous driving
if that goes
equipment,
wrong,
and it goes wrong, you get an accident, somebody get killed.
Absolutely.
Right? So
press fit is either works or it doesn't. And if it doesn't work, you can't. And then
let's rework it a bit. It's not possible.
It does not rework. It's almost like a security feature as well.
It's a security feature. Yeah, it's safer.
Yeah,
so of course we can talk about the environmental thing. You don't have soldering process, so that's also a green effect.
I mean, it's good. But I don't think it's anywhere near as important as the security aspect.
Is the big
absolutely.
One, right? So
what's going on here?
That's the board-to-board connector. As you can see, basically that's.
So you can push two boards together.
Get two boards together, right?
So
you see the different board heights. So this is an 0.4. Press pin. It's actually so you have two. If you really zoom into it, there are two types of press fit connectors, press fit pins. So one is I would say eye needle, which you saw there.
Yeah.
But this is mini PLX. Mini PLX is kind of a U shape. Look very carefully. It's kind of U shape, right? Which actually like a comb like this, which also moves inwards, right, and therefore create a force.
Oh, so I see what you mean. It's trying to unfold itself inside the hole.
Correct. Yeah. So that's basically creating you the normal force you like that, and therefore the reliable interface.
And do you need to use that as you get smaller because the eye version you might not have enough material to sort of.
I think it's best to say there are also traditionally there are many flavors how press fit could be. Eye vanilla is the most, I would say, common, the most popular. Yeah. And also for our Open 2, we are going for eye vanilla. Right. So eye vanilla is it's I would say from a manufacturing perspective maybe more easier to manufacture. Call that way. It's more straightforward. This is more complex, but has different performances. So the advance in this one. But like I said, from a manufacturing perspective, I think the eye vanilla is more.
Fantastic.
Logical.
So, just one more question before we wrap this video up. For the engineers watching this video right now, if they want to get involved with press fit solutions and what ENNOVI offers, what would you recommend that they do?
So, if they really want to go for press fit, please contact us. Right. So, we're one of the innovators when it comes to press fit based solutions.
Innovation, ENNOVI.
ENNOVI. Yeah, it's true. And basically, then I think by working together, like kind of a partnership, I think we can basically guide them to use our solutions.
Fantastic. Well, thank you ever so much for being here today.
As well. Thank you.